the field, some people run faster than the other people. Nobody can ever, but nobody can ever, as like nobody can ever run
Maybe try
in
writing
a
it
way
down
that where
first.
they're running faster than the speed of light as a group, right? But within the group, they can move back and forth amongst each other. But the very first there always has to be like whoever represents the very front of that message can never exceed the speed of light. So even though they're changing
Oh my
positions
God.
rapidly, and sometimes they seem to be going backwards, and sometimes they seem to be going faster than the speed of light, uh, it, that doesn't change, right? And then if you want to send another message again, you have to send another group of people, and they're still limited by that same thing, where they can change places all they want, but the time that it takes to get from one place to the other can never exceed the speed of light. And that's kind of what is happening here with these reflections that are going on within the cable.
What are the reflections?
So you're saying that a vibratory domino effect can appear to travel faster than the speed of light, but not one domino can run the whole length faster than the speed of light. Is that what you said?
Exactly. So then your message, so what that does to you is it pigeonholes you in that you can never send the message faster than the speed of light. No matter what is happening in that group, they're trading places amongst one another, right? Like I'm in the front, no, I'm in the front, no, I'm in the front, no, I'm in the front. And so they'll sprint up
No, this
to
is
the person in
wrong,
the front,
dude.
and then they'll sprint up and
Well,
they'll slow down.
Let me follow up real quick. Didn't they eliminate this whole idea of the wire having frequency in it or energy in it? And the main point was it was a blip with nothing in the wire. They wanted to measure start to finish and time it. Didn't they do this, or are we all just kind of conjecturing how it's not possible that it went faster?
No, basically what happened
they
was
explicitly write that they put a frequency of roughly 10 megahertz, so between 9 and 11 megahertz on that cable. And in this area, in this frequency area, this cable with these specific length of these 5-meter pieces of 50 and 75 ohm impedance of that cable interferes with this area of frequencies. So you must apply the frequency first, and then you change it to another frequency, and then you get this interference pattern.
Okay. So
you cannot send a single signal with 5 megahertz or so, or 10 megahertz.
Okay.
It's like we need to create a course where you guys can communicate. Like, and like you gotta pass the course or something.
Let me hear Austin's feedback on it. I heard you.
Was
Good job.
what did the signal get turned? Did the detector get turned on and go back off as it received the pulses? Yes or no?
It detects an increasement in amplitude. So it basically detects higher and lower currents. And you need that carrier wave. You can, for example, you cannot transmit a radio signal and information over a radio without the carrier wave. So you need that carrier wave on the cable. And then over that carrier wave, you can then transmit or create this interference. This is, for example, how radio works. It's not a single pulse or so you're sending. You're piggybacking something on a carrier wave.
Okay, this is wrong. You didn't answer my question. Were they timing the pulses as they reached the receiver?
They were timing the voltage increase on these different measurement points.
No, they weren't. There was a receiver. It was registering when the pulse arrives. And then they'd wait a second and they'd do it again. It wasn't always on registering the change in between the receiver and where it was sent from. You're making that up. And that's because for you guys to make sense of this in your mind, you can't have it actually get to the receiver. The pulse can't get to the receiver faster than C. Right? In your mind, that can't happen, and your belief about it still be true. So you assume that can't be what's going on. We're trying to tell you that's what happened, and their excuse is it wasn't considered useful information. So it isn't a sufficient rebuttal to say if that were true, we would have faster than light communication. No, we wouldn't. Right? And they're classifying that as useful information. And what actually happened is when they set the test up this way, and they can use there are two different types, unlike what he was saying earlier, which is that it was all the same type. No, there's the alternating cables, or you can use a photonic crystal to attain the superluminal pulse propagation. And there's a distortion that takes place. There's a distortion in the signal. So when you set up the test in such a way, and this has been done for a while, but this is the first time it was done with like much greater distances, and it was much faster than C. It was 3 or 3.5 C, as opposed to like 1.2, 1.3 C over a much shorter distance, right? This was a longer distance, and it was up to 3.5 C. And so they set the test up using these alternating coaxial cables, right? Are these cables that give you the coaxial cable, right? And one of them has an impedance of 50 ohms, one has 75 ohms, right? And they'd alternate these. And then the pulse would go through them and it could get to the receiver at 3C. The other thing they used was a photonic crystal, which logically speaking, we would think would slow down the propagation, right? It didn't. The pulse propagation was faster than C. What their out is, and I just read it, right? They say, oh, well, it depends on how you define this. Like on its face, it looks like this would violate relativity and causality, right? But it depends on how you define causality and information. And this doesn't technically violate causality because it isn't useful information. And what actually happened in very simple terms is the signal was distorted. So like if we were going to try to apply this in real life so we could have fast and live communication. So for example, when we're going to talk on Discord or play on Xbox, right? Like we wouldn't be able to utilize this method because there would be distortion. So the signal would lose its like the useful characteristics in that sense, right? If we sent the signals, the information with that frequency, with a setup akin to this test, it would become distorted. So I wouldn't be able to talk to you like I am right now. So I understand why you
use it?
logically do.
Witsit, couldn't you use it? All right, go ahead.
Good. No, you're fine. Good.
Well, couldn't you use it so that if you even see this frequency, then do this? Wouldn't that be a kind of sending information?
Well, yeah,
like
but
if you,
yeah, you could. Yeah, you could understand how it gets distorted, and then you could, have some system set up or whatever, right? But you can't really control the coded like coherency of the signal. It just becomes distorted. But like I understand where Jake is coming from in his mind, which is like, no, it can't be true that they're actually sending the information from point A to point B faster than C, or we would use that. These people would be multi-billionaires. We would use that, and we would have faster than light communication, right? Like that's a reasonable instinctive response, but again, there's a distortion that takes place. And so we're going to throw this whole information, useful information. Let's just throw that out.
But
Like
what's
Diego
the
said it very well.
distortion?
It was
Because like if you can just send a blip from one end to the other, that's not distortion.
But there was some type of distortion.
But it's just on or off, right? Was it not all the way on, or like what was?
No, it was on. No, I agree with you actually, right? Which is like for the intents and purposes of why we're presenting it, it's pure. It's fully useful. I don't, but there was a distortion.
That's not distortion. We should be able to send bits across.
Well, they're saying that
and do faster than light.
They're saying that the bits would be distorted.
Like,
how
do bits get distorted? They're on or they're off?
Information can be anything.
I'm going to tell you. So there's a destructive interference. That's the answer. There's a destructive interference in this test.
And how does does that cause something to flip on? And like, because you're saying we're sending an on signal, something's destroying that in the middle, but then somehow we're getting the on signal on the other end.
So
you're saying words right now that are coming to me, right? And we're using undersea cables to do it, right? There would be a destructive interference that would distort the signals if we integrated like photonic crystals. Also, it wouldn't be practical at all, right? But it doesn't really matter.
Why not? Because listen, you're okay. You're arguing that they send a pulse from one end, and it went faster
I'm
than the
not
speed of
arguing
light,
that.
and
That's
it
what
hit
they
the.
argued.
Don't interrupt. It goes from one end to the other faster than the speed of light, and on the other end, you sent the on signal. On the other end, you got an on signal. That's not distortion.
I just explained it, bro. So like if you're just gonna repeat it like I didn't rebut it or something, then like I don't know. And I said it wouldn't be practical. Like we're not gonna go to the undersea cables and put photonic crystals on them anyway. And furthermore, there would be a distortion of coherency because of the destructive interference. All of that is non sequitur, though, to our point. And I'll read it again. This is the still man of your side. So if anyone wants to come jump in and say relativity wasn't violated, you should properly represent your side. Not this weird, well, we're on Discord and we'll just revise it and say, nah, okay? It says it in the paper. As in the case of analogous optical experiments, this highly superluminal group velocity can be understood as an interference effect between spectral components of the pulse. In the highly dispersive band gap region, frequency components tend to interfere destructively in the tail of the pulse and be reflected backward. This effectively shifts the peak of the transmitted pulse forward in space. Although superluminal pulse propagation appears to violate the principle of causality, the issue is mostly a matter of definition. Group velocity, defined as the traveling speed of the peak or center of gravity of the pulse, can indeed exceed c or become negative. However, since the transmitted energy is at all times smaller than that of an equivalent pulse traveling through free space, no useful information can be sent at superluminal speed. Saying it doesn't violate causality because if you interpret useful information in the way that they present. It literally says it right there. It says it says that it gets there. It's propelled forward in space to the receiver faster than C.
Well, that's what
Like
I
it
tried to
literally
say.
says
That's what I said. That's what I said a while ago. Let me say this real quick. That's what I said a while ago. Information is literally just cause and effect. If you cause something to happen and it makes an effect somewhere else, you're sending information. Whether it's useful or not doesn't matter. Information itself is not supposed to be faster than the speed of light. And according to what you just read, it seems like they're saying that information, no matter if it's useful or not, is traveling faster than the speed of light. And that is supposed to be absolutely impossible.
Oh, dude, if you can't understand it, go ahead.
Just briefly, I just want to make
hold on.
one last
I thought
attempt.
that was Witsit. Hold on, let me respond to what he said directly,
Okay.
please. It's only information if you can understand it. If you can't understand it, there's no information.
No, information is anything. Information is if you got a wire and you flip a light switch on one end and it turns a light bulb on the other end, you send information. If you got a pole and you push on one end and the other end moves, you send information. That was the point of me talking about the thought experiment a while ago about the pole from the Earth to the sun. If you push on one end of it, it's not, the other end isn't supposed to move until light could travel that same distance and get there. You would think the whole pole would move all of a sudden, but what they say is all the molecules would have to bounce off each other the whole way at the speed of light, and then the other end 8 minutes later would finally move from the time you pushed it. You're sending information, but it can't do it instantaneously. But according to this, its information is moving faster than the speed of light.
If I send you if I send you a whole bunch of garbled letters that you can't understand, there's no information there.
Can I try again, please?
Well, it's not
That's
that the
just a fact.
information's fast. It's the average. Remember what he said? The average.
You're thinking of information though as like something that we use to think and to talk and everything else. That's not what scientific information.
Oh, did you hear the part where he said average?
Yeah, I'm on like Witsit side here. I'm not on the Glob side here.
I want to go after that guy.
Please
Yeah,
try again.
You go, and then I want to say something. Go ahead, buddy.
Okay, thank you. So I again posted 20 minutes past the hour, so like 4 minutes ago, this picture, and the information that is sent is in this picture is basically this red dot on the lower line that is fast moving faster. At the moment, we have a standing wave and a standing interference. Just imagine these two frequencies at the top are completely lining up with each other. So you have basically the same frequency below. And this is on the sender side. So you basically have on the sender side two frequencies. These two frequencies interact with each other on a continuous pattern without anything moving faster or so. And now you want to send an information to the other side using this interference pattern, where this interference pattern, so the third line at the bottom, is moving quicker. And you want to transmit these fast traveling red dot quicker, which means you change one frequency and then you get an interference pattern. But the one frequency that you change travels with the speed of light in that medium. So let's say it would be super slow. It travels 1 meter per second. So after 1 second, you have on the first meter of that cable, you have this interference pattern. But on the other, let's say 25 or 30 meters of the cable, you don't have an interference pattern. So in the next second, the frequency travels 1 meter further. And then you have 2 meters of this interference pattern where you have fast moving information. But the thing is, the change in frequency does not arrive the end of the cable quicker than the speed of light. What they measured is not like you change something in the beginning and that directly travels 3 times the speed of light to the end. It is just like you change a frequency on that coaxial crystal, and that causes this center of mass, this blob there, moving quicker than the speed of light. But you cannot transmit this information quicker than the speed of light. You first have to apply that frequency. That frequency travels with the speed of light, and then you are on a medium that has these periodic pulses coming quicker. So you cannot encode anything quicker than the speed of light.
Okay. Now, clearly, you've just completely revised your position. It's all good, right? Completely revised the whole thing you were arguing this whole time while you were claiming to understand the paper. That's
Nope.
fine. But yes, you did. So now we are saying there
Nope.
was a pulse that was sent and received at faster than C, which is accurate. And this is their out. They say it wasn't quote unquote useful information. This is a major problem, though. Okay, so maybe we need to define some of these things for the room. Okay, like I'll try to do this in really simple terms, right? Like if you want to go back and forth with me or whoever does from your side, then maybe we can actually make this digestible. Okay, this is all
I
about
said
cost.
I said seriously, I tried one last time because I'm now going to bed, so you can go on. I'm not interrupting you anymore. Go ahead.
Nobody needs to know your nap time.
Okay, well,
It's
it's
2 a.m. here.
Yeah,
yeah,
nobody needs
but
to know that.
does this not even make you question your worldview at all, bro?
Oh, every time I talk with you, it questions my worldview.
Okay, man. So does another Glober want to? Do the Globers know what causality is?
Well, that's the
Okay, so
semantic part, right?
I mean,
well,
I
it's just
know
an
what
That's
issue if
it is.
we're
where it becomes
Well,
semantic.
it's not a
It's
big
like
deal.
information a while ago. That's
it's
Yeah,
what
causing the
information-
receiver to trigger, right? But they're saying it's not a causal. It's not
Well,
the
yeah,
causal
I mean,
part of it,
to-
but it's like
to
it's
be
causing a fucking trigger in the receiver.
To be fair, right? Relativity can be confusing, and we are not taught relativity in school, really, maybe in university, and it's rarely digestible. It's no big deal. But like we are operating under the assumption that causality is understood, and it seems that may not be the case, right? Like in really simple terms, right? It's a cause must come before its effect, right? And no signal can move faster than light because that would allow the effect to happen before its cause in someone else's reference frame. right? So like if you could send something faster than light, then according to relativity, another observer, right, moving differently, could see that message arrive before it was sent. And this would break the concept of like cause and effect. So relativity places everything is relative. All motion is relative. There's only one thing that's absolute in the universe, according to relativity, and that is the speed of light. And it's universal for all observers and all reference frame. For one, you have to have something absolute to compare against, right? To even make sense of anything relative, you have to have some objective standard. The standard Einstein uses is the speed of light, c, right? So we have like our absolute standard to compare everything else to try to understand it, right, in relative terms. So relativity says nothing that carries energy, matter, or information can go faster than c. That is a major problem when it comes to this test, because that receiver could not be turning on, right, unless it was turned on by energy. So
Which would
the
mean
paper,
information is traveling faster than light, right?
yeah, there's energy going faster than the speed of light. We can actually avoid the whole information conversation in reality, like altogether, right? This paper doesn't even sufficiently rebut it. To be fair, it just says it doesn't violate causality if you define if you interpret it as meaning only a limit to useful information, and this information isn't useful. But it's actually just about energy anyway. It's matter, energy, information. None of those things can go faster than the speed of light according to relativity.
What I'm
Well, that was gonna.
trying to say, though, the reason I keep saying information, because that covers everything. That covers it all. If you send an electrical signal down a wire and it turns a light bulb on, you send information. It don't have to be.
Well, I agree.
Information is not the word that we use, like you sent a text and that's information.
No,
That's
I
not
agree with
what
you. Yeah.
information is in science. So that's
Yeah.
why I
No,
keep
I
saying
agree.
information, because it covers everything. That's why I keep
I agree, but this room is clearly having a bit of an issue with information. Right? Like the reason I'm bringing up energy is because one thing we can know for sure, whether we want to call it the information useful or not, is that it required energy for that little receiver, that little light to come on, right? Energy is required. So energy hits the receiver and turns it on. Energy interacts with the receiver. From our framework, this makes perfect sense, right? Ours meaning like an etheric framework. Light is nothing more than a background medium. It's already there. It doesn't physically travel from point A to point B. There is no finite speed limit, as in travel from point A to point B, right? It only has a speed in the sense that there's a rate of induction and it's perceived as illumination when we talk about visible light, for example, and it's not only visible light anyway. So like that makes perfect sense. Like this receiver, the light that the quote unquote, well, it's actually an electrical signal, right? Like it's already there. It's already where the receiver is. It's simply about a perturbation of that background that changes the modality so that it does interact with the receiver in such a way that it turns it on. But like we can set all that aside for a second before we get into like the depths of the viable replacement. I just want to make sure everyone understands. It's very simple. The pulse goes to the receiver, and Piezo explained it super simple, right? Like envision like a little box with a little red light on it, and as it receives, it's a receiver, and as it receives the pulse, it lights up. The little red light turns on, and so and then they wait a couple seconds and they do it again, and then do it again. So what you would see if you're looking at this test is you would see some coaxial cables or photon, like little crystals, right? That the signal's going through. You're going to look at the light and it's just going to go beep, 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 right? The point is they were trying to say it as though the light was always on and that they were just looking at the differences within the cables, like basically moving up and down. And that is not what happens. Right? Like there's a pulse. They're literally measuring the rate at which the pulse reaches the receiver. So how
that
can this
paper
not
that you
violate
read?
relativity?
That paper you read, is it in the chat? I want to read it again.
Yeah, I'll drop it again because it's probably pretty far down.
Yeah, I want to read it.
Yeah, and
It's like
Witsit,
saying part of the. Oh, go ahead.
all right, real quick. the way that I'm thinking about it, honestly, the point is almost like a 100-meter track runner. Like the point is a person with a stopwatch. You notate when you say start or when you send the signal, and you notate when the light turns on. All that matters is the timing, boom, and how fast is it? And you can calculate, is it the speed of light, or is it 2 times or 3 times faster? Now, the whole argumentation of, well, there was a signal sent through already at the speed of light, and then there was an interference pattern or a different beep or a different tone or a different voltage of electricity or a different anything. The point is, when you make it different on the one end, that gets to the other side faster, 3 times the speed of light. So all that matters is they achieved what they were trying to do. Is see if the limit was the speed of light. Looks like it's not.
But
And so
it's more like you try to pass a ball to the other side of a football field, but you're not capable to throwing it at that point. So you run with 20 people, you start running, and then you pass the ball from the behind running person to the front running person, which actually means like the ball can travel faster than the runners, but you can never get the ball quicker from the one end of the field to the other end of the field faster than the fastest runner. So if you start running and you run, the group starts running, and the fastest runner is close to the end of the field, and then you start passing the ball very quickly, that means the ball is actually quicker than the runners, but the information like run and give this signal is not traveling faster, because the fastest runner has to reach nearly the end of the field because before that runner can pass the ball. And that's how it works. So you have to first propagate the runners equally on that cable to then get the interference pattern, the ball, running faster than the speed of light.
So
Well,
the
Snooze, let me respond to
Yeah.
Snooze real quick, because it sounds to me like that's a well thought out, and you really put good word play in my mind of how it could happen. But in this experiment, I think the experimenters know where point A is the beginning and where the point B, the end is, and they know when they hit start or change the frequency or change the tone or send the blip. They know that the beginning is there. That's where the calculation begins. And B, it got there faster than the speed of light. Now, they say no useful information was sent. Now, I don't care if they were trying to send the letter K to pop up on a monitor on the other end. And if they say, oh, we can't do it, bro, all they had was a rudimentary light, right? A red light that would come on. They knew point A, they know point B, goal, turn on red light. And they did send something faster than the speed of light is what it looks like what the paper says. Am I wrong?
The paper says that the balls travels faster than the runners. That is what the paper is saying. And the paper explicitly says that you cannot transmit useful informations because you cannot send the ball to the other end of the site before you told the runners to start running. And that's exactly the point. You can even if the first runner runs and they constantly throw balls. So you have basically this constant information. You don't wait until the runners have propagated through the field. You constantly start throwing balls, which means all the balls are always traveling faster than the runner in the front, but no ball reaches the end of the field before the fastest runner is in throwing distance of the end.
Okay,
And
so
that's
in
the
this
exact point here. You have to pass the information between the runners, and that cannot be faster than the runner itself.
so the runners are photons, right? Am I correct?
Yeah, kind of. And the ball is the interference pattern on top of these photons.
The phase shift or whatever is the ball.
Yeah, so you're saying the interference travels faster than the speed of light, but the information doesn't.
And the interference travels faster than the speed of light, but the kind of
the information
start.
doesn't.
So the information, like start the interference now, is not traveling faster.
Right, but part of it, something traveling faster than light. Something, somewhere, somehow, whatever way
This
you
is
want to call it.
this is known though. This is like basic quantum mechanics, bro.
If you look at the GIF that I posted
You can
in
see
the
how
live stream
interference can
one,
move faster than the speed of light. Somebody talking, I heard something mumble. I might overtalk somebody.
Yeah, the phase shift moving faster than the
It'll
group
be sort of like
velocity
saying
is a well-known.
Be like saying if you shine a flashlight at the moon and you moved it from one side of the moon to the other. If you was on the Earth and you could shine a laser beam at the moon and you could move it from one side of the moon to the other real fast, as fast as you could, that laser beam would move faster than the speed of light from one side of the moon to the other. But it's not really. There's not really something moving faster than the speed of light. So is that what you're trying to say? Is
analogous,
the
yeah.
interference pattern is what's moving faster than the speed of light? Because I can understand that happen.
That's what it's saying. Yeah,
saying
that's basic. That's basic quantum mechanics, bro. That's a 101.
The pulse takes on a new shape.
Look at the GIF that I posted in the live stream one. You see the peaks are moving across faster than the wave is being, than the wave front is moving. It's those peaks moving forward that's moving faster than the speed of light, but they cannot get anywhere in front of the actual wave that's being propagated. That's what it's saying.
You're really mumbling. You're really, I don't know, if you have your microphone somewhere in your pocket or so, it's really not really sounding good. But we explained that already multiple times with different animations, also with the animation that you had.
Well, for fun, can we hear what other possibilities it could be? I think Witsit was about to say like what it could be or another answer, but I don't have much time just because the family's coming back from something. If you're here, Witsit, were you going to do that? I could always catch it on
But
replay.
we already debunked all this. They just keep saying the same thing. But we already debunked this. Like, there's a receiver. It doesn't turn on until it receives energy. The energy turns it on. They count. They are literally taking the speed of these pulses one at a time. They're doing them over and over and over, and that the energy is hitting the receiver at faster than c. Okay, trying to say that the car didn't break the speed limit, but the engine did go faster than the speed limit is just goofy double speak, and they try to redefine useful information, right? When the reality is that there had to be energy propagating faster than C for the receiver to receive the signal to turn it on, the pulse that turns it on, which has to be energy at 3C. Right. And that's what actually happened. And they've gone through 4 different ways of trying to claim that this didn't happen. First, it was like only the leading edge of the wave carries information. Okay, if the center of the wave is going faster than the speed of light, then does the front leading edge of the wave get there before or after the middle of it?
The front gets there before the middle.
Okay, so then if the middle's going faster than the speed of light, the front would have to. That isn't an escape. It's just some weird double speak. What they try to do in the paper, and I'll read it again, right? They claim that they just don't qualify this as useful information. That's all they say. That's what they say.
The front of the wave doesn't have to travel faster than the middle of the wave. It just has to be sufficiently far ahead of the middle of the wave.
Well, which one of the waves is turning on the receiver?
The phase shift you're talking about.
The receiver's just an oscilloscope.
They send a pulse. They send
measuring
a pulse.
Frequencies.
It's not just measuring frequencies. It sends a pulse. They're measuring the pulse velocity. So yeah, the room just baselessly claimed that it was on the whole time, and they were just looking at the center, and they're like, "Oh, look, this is moving faster." That's not what happened. There's a receiver. They're measuring the velocity of the pulse. The pulse gets to the receiver, 3C, which is why in the paper it says this appears to violate special relativity. Right? Although superluminal pulse propagation appears to violate the principle of causality, according to you guys, it doesn't even appear to do so. But you're just totally revising the test, and it's been revised like 5 times now, right? By the other side. Now we're admitting that there is a pulse that's sent faster than C. A second ago, it was on the whole time, which isn't true at all. So that's why they say it appears to violate relativity, right?
Well, a pulse is a surge. It's not like 0 to 1. It's more like 1 to 2 back to 1.
The pulse propagates.
The pulse is this what they call the center of mass of that group propagation, of this group pattern.
Right. So now we have
So
to
what you see in the
articulate some
animation of
intelligible
Echoplex,
way.
that is the
You
pulse that
very
is
clearly
moving
paused and
forward.
then decided to say something else. Okay. You have to articulate, and I said this 20, 30, 45 minutes ago. Right. I even told you guys what the stillman of your side is, and they claim it just wasn't useful information. Everyone gaslit me. Sorry, I got a call. Everyone gaslit me, acting like I didn't know what I was talking about when they hadn't read the paper, blah, blah, blah. Now we're finally to the point where we are getting there. Okay. You have to explain how group velocity is not considered information, but a single wave velocity is. That makes no sense at all. The group velocity is just taking all the waves, treating it as a group, as a single entity, right? Like
I
the constituent parts make up the whole. Okay, so explain how group velocity is not information, but single wave velocity is information.
I already explained that with these runners. The single velocity is the front runner running, but the group velocity is the runners in a specific distance passing balls to each other.
No, it's
So
not.
yes, it is. Because
No, it's
it's an
not.
interference, it is an interference pattern on a carrier wave. So the wave must be there, so the runners must be propagated over the field before you can send the carrier wave, before you can send the interference pattern on that carrier wave. Only two matching carrier waves have interference patterns. So if you move, for example, even if you say the runners are already propagated over the field, the change in, for example, distance between two runners, if you want to change the distance between two runners, this is basically a change in frequency, can only happen in the speed of the runners running. You cannot change that quicker than runners can run. And
Totally
this is
butchered
exactly the point.
analogy.
The information is when you send the first runner running. So, like, okay, go. And that is the information. And then between when the first runner is at the 10-yard line and the second runner is at the start, you can pass a ball. That means the ball between you and the 10-yard line is faster than the runner, but the runner is just at the 10-yard line. He's not at 50 yard or 500 yard. So he has to run 10 yards more. Then you have another runner at 10 yard, one at 20 yards, which means from 0 to 20 you can pass an information quick, but not to the end of the field. It can never propagate quicker than the fastest runner. And that's exactly the
It
difference between
literally
the
did,
group
though.
propagation, the balls, or the single propagations, the
This is
runners.
so stupid. It literally did, though. The analogy doesn't even make sense for starters. You would have to say that there's like three runners, and you're treating all three of the runners running the race as a single entity. It has nothing to do with passing balls.
That's what it is.
Oh,
That's what a group.
he's
That's
talking
what a
about
wave
passing
group
balls.
is.
He's talking about passing balls. It's nothing to do with passing balls. There's nothing else. It's just the runners. You have the one runner, or you have a bunch of runners. You're just going to treat them as a group. What happens is the receiver, they send a transmission. The traveling speed of that pulse that triggers the receiver exceeds c. Okay. So that's the question. Does the traveling speed of the pulse exceed c?
The pulse is the interference pattern. And interference pattern can only travel on waves that are different to each other. So if you have two waves that are same and you change one wave, the front of that interference pattern, where it always stops interfering, can only travel with the speed of light. But at that part that has already traveled on the speed of light, on that, the interference pattern is quicker. So no, you can not. It's
That
not a
isn't
single
what
pulse.
happened.
It's not a single pulse that you are transmitting. You are transmitting an interference pattern, and you need a carrier wave for that. And that carrier wave cannot travel faster than the speed of light. And the carrier wave is the information that you can send.
Does the traveling speed, does the traveling speed of the peak exceed c?
Yes,
Yes.
it
Okay.
does,
Okay.
but
Is
that doesn't
no,
transmit
stop.
any
Don't repeat your same
information
retarded
because the
analogy for the
carrier
seventh
wave
time.
is not traveling faster.
Well, it's funny that you're saying it real slow when the first 3 times I asked it, you didn't
Because the
answer the
two is
question.
the same.
Okay, this is where he gets to just interrupt. This is pretty cool. So you didn't answer the question. That's why I've had to repeat it 3 times. To try to act like I'm stupid and you have to say it slow is just goofy. It's funny how
You
once
did
me
it
and Piezo,
exactly the
and there he's
same
interrupting
with
again. It's
you
funny
made it
how you
so
have to
slow, so I
interrupt. It's
just
funny how
responded like
when
that.
you just claimed it. It's funny how you claimed you had to go to sleep a second ago. It's funny how when we broke it down and corrected you, you just all of a sudden got quiet. It's funny when we asked you the questions directly that refute your position, you didn't respond. Right? It's funny how you just told the whole room actually like I didn't know what I was talking about or how the test worked and pretend to teach us how it worked, and you were wrong for a full hour, completely wrong fundamentally about how the test worked. Then you conflated the oscillating impedance of the cables and the photonic crystal as being the same thing. Like
There is
fundamentally
no
didn't understand.
oscillating impedance. There is a
Oh, oh,
periodic
oh,
impedance
oh!
change.
I
It's
think
not
he's accidentally
oscillating.
interrupting. That's crazy. That's crazy. So first he
You are
tried to
just
say that.
using words where you have no clue what they mean. There is
So
no
first he tried.
oscillating
I know you're
impedance.
desperately trying to make sure that you can hone in on whatever you can, but acknowledge what happened. It's all
With
recorded,
it,
by the way.
just
Don't stop
just
interrupting me,
say
dude.
that there is
Stop
no
interrupting me, dude.
oscillating
Why are you
impedance.
interrupting me,
It's
dude?
just bullshit.
All right,
Because
Why are
you
you
are
guys.
interrupting me,
bullshitting.
dude?
Snooze.
Why do you think that you can just do whatever you want? So you first tried to tell us that the 2 different impedance cables were the same thing as the photonic crystal. You didn't even know that it was 2 different things. This is where you go mute again.
Go on. Is there anything that you ask me?
Okay. So did you will you acknowledge that you were completely wrong and misunderstanding it fundamentally and didn't even understand what it was saying at all?
Yes, I do disagree with that.
Well, did you conflate the 2 different cables with the photonic crystal?
No?
You did. It's recorded. And I explained the impedance of the photonic crystal. You then stepped in to act like you were correcting me, and then you explained the cables when they're 2 different things. And then I corrected you and pointed that out, and you did this right here. You stopped responding. Then when Piezo was in here and we were both breaking it down, and he was breaking it down in very simple terms and asking you very simple questions, you just stopped responding. Then Piezo left because no one was answering him, right? And then you jumped back in. Then I asked you the point blank questions that you couldn't answer. Then you said you were going to sleep. So then a couple of people jumped in to try to say it in really simple terms. Someone else. Then you wanted to jump back in and repeat the thing that had already been debunked.
Do you have a
So that,
question or are you just whining around?
okay. Does the receiver require energy to turn on?
Yes.
Does it
But
measure?
wait. It's not on and off. It measures voltages and over a frequency. They used an oscilloscope to actually measure these change in amplitudes.
It's measuring the velocity of the pulse. That's what it says.
They
No
have
matter how many.
multiple measurement points over that distance of 120 meters. They are not looking to a pulse traveling quicker. They have multiple points. These points are synchronized to each other. And then they see a peak happening. And that peak can be measured or recorded with a timestamp. And then afterwards, you can look in these data that these different recorded peaks on these different measurement spots are actually closer together from the timing than the speed of light. And it's not like receiving going on or so, it's exceeding a threshold. And that threshold can then be calculated out of the data recorded.
Where does it say that they're measuring along the cable? Where in that paper? Because I didn't see any of that. But I could be wrong. I'm just saying
They
I
say
didn't
it
see
in
it.
the cable. I can dig it out, but you can also find it yourself. It's in the paper.
Yeah, that's what I'm saying. I tried. Like, because you made that
No,
claim
no, no, no.
earlier.
When
I couldn't
Piezo was in
find
here and corrected you, you just stopped responding. You claimed it was just always on. You got corrected, and then you just conveniently stopped responding.
No, I
Now you all
said
of a
there
sudden
is
aren't
already the
leaving the
carrier wave
conversation,
is
and you're
on the
just
cable.
repeating
That's
it
what I
again, and
mean
now
with
you're
it's
doing the
on.
interrupt me thing again because that's what you do every time. I can sit here quietly and let you fully say your
The,
point, but every
the
time I go
five
to
times
respond,
You keep
before
misrepresenting him.
when I don't respond,
I'm
the
not
5 times
misrepresenting
you were
anything.
whining that I got mute. Now I'm responding to your
No, you're talking through
accusation,
me.
and you are whining again that I'm responding.
No, actually, you're talking through me. I'm not whining
No,
that you're
I'm not. I
responding.
just
I'm talking
respond
about
when you make a pause.
no, I didn't pause.
You did.
No, I didn't.
And the last time when you did a pause and I didn't respond, you accused me again from mute that I muted.
But what are
Okay,
they
dude.
measuring?
You
The interference?
know what's
Is
so
that what
funny is
you're
it's
using
all
against them?
recorded. It's all recorded. What you've done for the last 2 hours is literally all recorded, but you don't care because you're like, I'll just lie about it. This is why I then say, you want to bet $1,000? None of the Globers ever take the $1,000 bet though, because they're lying. Okay. You were wrong about this test. What happened for who wasn't here? I brought this test up. 5 Globers jumped off their mic and acted like they knew that it wasn't true, and I made it up. Then they acted like they knew nothing could go faster than C, and I was just lying. Then they demanded the paper. I got it for them. Within 2 seconds, they pretended they knew that what it meant. And then, pretending to teach the room what it meant, he tried to get a bunch of gotchas on me. And what came out to me, what we found out was he didn't even understand the basics of what the paper was saying, even in the abstract. And he conflated the coaxial cable and the photonic crystal. That's fine, but that's what happened. Okay. So to try to rearrange and revise it as though you've been saying this very simple explanation this whole time, no one understands it. That's not what happened. And the paper itself explains towards the conclusion that it appears to violate causality, and that the only way you can claim it doesn't violate causality is dependent upon definition of information. And they are choosing a definition that doesn't identify this as useful information. Right. So
That's
can
what I. That's
you
what I. That's what I
can
keep
the
trying to ask.
can the snooze guy articulate with substance and specificity why this isn't useful information, and how does that rebut the fact that according to relativity no energy can go faster than c?
Yeah. So first, what you are talking as a coaxial cable and then a photonic crystal, they used a coaxial photonic crystal. That is the cable. There is no second cable or so. And that coaxial photonic crystal has 2 different impedance. They used 2 different types of coaxial photonic crystals. One was 75 ohm, one was 50 ohm. And they spliced it together to one cable. And over that one medium, they send the information. And again, and I have it already said multiple times, you need to have the carrier wave to transmit an interference pattern. So that carrier wave must already have arrived the receiver at the end of the line, so that then an interference pattern can travel the whole way. If the carrier wave has only reached the midpoint, when the interference pattern starts, it only points to the midpoint. And that's exactly the point. You cannot transmit any irrelevant information quicker than the speed of light, because the carrier wave needs to come to the end first, which is the point, which cannot you cannot send something from the back without the carrier wave traveling at speed of light. Nothing can receive the end before the carrier wave change or the carrier wave frequency change or anything reaches the end first at the speed of light. So it's a
You didn't answer the
secondary
question.
information, which is the interference pattern.
You didn't answer
Therefore,
the question.
it's not useful.
You didn't answer
That's
the
what I
question.
keep trying to say over and over and over. If I can get in here and I keep saying it. They're measuring the interference. Is what they're measuring. That's what you keep saying. They're measuring the interference. So if you start an interference pattern on one end and it reaches the other end faster than the speed of light, that in itself is information traveling faster than the speed of light.
Correct, but that's not what's happening. You cannot start an interference pattern. Wait a second. You cannot start the interference pattern on one side, because to have an interference pattern traveling, you need two waves that are interacting with each other. So if you start one of these two waves, or the one signal on these cable that has a resonance inside, if you start changing your frequency that you send in the cable to create the interference pattern that then travels faster, this change of the frequency on that cable travels with the speed of light. Which means, even if you start sending or try sending an interference pattern from one side, your change in frequency on the cable has only, for example, reached the midpoint, when already interference pattern on the first half of the cable happens quicker than the speed of light, but only when this wavefront of your changed frequency has reached the end, also the interference pattern can reach the end, which is exactly the point in no useful information. And if you then try to change again the frequency to get a different interference pattern, to again transmit different information, that change in frequency again travels with the speed of light to get another interference pattern. So you have
You
no
exactly what you're
possibility
saying.
to encode anything in different interference patterns, like on-off interference patterns or so, quicker than the speed of light. That's exactly the point of the paper.
Following you to a T on what you're explaining. I pictured it in my head as you're talking, the way it's working. But then why does the paper say it appears to violate causality?
Because it only appears to violate a causality, because the interference pattern is traveling, but the cause that is creating this interference pattern is only traveling with the speed of light. So this
The
wave
interference
front
pattern is a
of the
secondary.
area,
It's not a thing in itself. It's a
yes,
secondary thing. It's a
It's not how.
composite.
That's not how it. That's
The
not how
pho-
this works.
the photons are the only things traveling. Like the photons can't exceed the speed of light. The
yes.
No, but
interference
they
pattern
do.
is a the interference pattern is a it's not a photon. It's a component of a photon. So the
Well,
component is traveling faster than the speed of light. It's a secondary
bro,
thing. It's not like a
an
It's
interference
like an
pattern is a
echo.
bunch of photons intersecting with each other.
Yeah, but
But
it's
how does
like an
that happen?
echo. So
Hold on, Snooze.
the echo can never appear before the direct sound wave appears. So let's say we are in a room and I call something, and
I
you
thought you
say the
just said
echo
your whole thing.
is receiving you first. That's
Dude,
not
come
possible.
on. All right,
yeah,
so
Like you
Snooze.
said,
You need
echo
the way
center of
I'm
gravity.
the way I'm understanding it is like you have this spotlight, right? And it's a bunch of photons, right? That are causing this effect to appear. But the actual spotlight is moving faster than the photons can actually keep up. Right? That's kind of what you're saying?
That
That's
yeah,
how I'm getting it.
that
Because the
laser.
photons can't actually move faster than light, but the illusion or what appears to be happening is the result of what the photon displays moves faster. So it'd be like a spotlight, or that area that gets illuminated is actually traveling faster than the photon can reposition.
Yeah, Cole's analogy of the laser against the moon, moving the laser across the moon. The appearance of where the laser is facing, like where the laser is facing or whatever, appears to travel across the moon faster than the speed of light. And this is just in a Glober paradigm, just to fucking whatever. We don't have to say this is real, but in the Glober paradigm,
Yeah, we got
the
you.
light is not actually the light is not actually traveling to appear. Sorry, the light is not actually traveling faster than the speed of light across the moon. It just appears to that image, that secondary thing, which is like analogous to the interference pattern. It's not a thing in itself. It's a secondary thing that is traveling faster than the speed of light. But the primary substantive thing, the cause, i.e., the photon, is not traveling faster than the speed of light.
Well,
Yeah,
then how is it the cause? If the
you had a
effect
laser
is
pointer.
if the effect is not consistent with the cause, how are we calling it the cause? Like the effect is going to be like the end result, which would be the end of the laser, right? And if we're going to say the photon causes it to illuminate here, but this cause, this isn't actually,
Because the first
you know what I mean?
photon, the first photon already made it to the moon. Like you don't see any signal on the moon before the first photon gets to the moon. Once the first photon gets to the moon, then you can see this I guess apparent or illusory faster than light travel of where the light appears to be on the moon. But the
Yeah, but
first
Exactly.
particle, like the first photon, it took the speed of light to get there.
yeah, and
That's
It's
why
if
like
you're here
saying
on
the
Earth,
effect is before the cause, though. You know, when
no,
you
it's not.
explain it like
No,
that,
the effect can't
because
precede the
like
first
the
photon.
end result moves faster than the source of the end result.
The
No,
end result cannot precede the first photon. The
and
first
also if
photon
you're here
goes
on
and gets
Earth,
there. Once the first
Snooze,
photon
shut up.
gets there, once the first photon gets there to the moon, you can then have the illusion of the image of the laser moving across the moon faster than the speed of light. But the
That's not
first
analogous.
photon
This isn't
actually
an
has to get there
illusion.
first.
This isn't an illusion. These are physical instruments measuring a wave pulse propagation that's faster than the speed of light, which is energy by definition. According to relativity, you cannot have energy, matter, or information go faster than the speed of light. So this like ad hoc get out of jail card where we arbitrarily redefine what is or isn't useful, we point to the fact that there's a leading edge of the packet, and therefore anything behind it that does actually go faster than the speed of light somehow isn't violating relativity. It requires a careful ad hoc redefining of information, useful information, and causality itself. There is energy that is moving faster than the speed of light. I don't care what is before it. I don't care about any of that, right? Relativity says energy can't go faster than the speed of light. What happens in this test, in very simple terms, is once there's an interference, it propels the wave forward in space. It propels it forward. It leaps forward, right? And that leap ends up resulting in a propagation rate that exceeds c. That's not supposed to be able to happen. Energy is not supposed to be able to go faster than the speed of light. This is why in the paper they say, on its face, it appears to violate causality and relativity, but it just depends on how you define your terms. And we're going to say it
Yeah, but
doesn't
that's all
technically do
base.
it because
That's
this
all
isn't
basic. That's all
useful.
basic stuff, dude. You're not arguing against the mainstream. Like this is all basic. This paper, like based like their findings, is what they base quantum mechanics 101 at your university on. Like the idea that group velocities move faster than c is in quantum mechanics 101.
Of course, that isn't the
That's,
point. Yeah, I read that off, and it's specific to quantum tunneling, right? But that isn't the point. I don't care what the mainstream does or doesn't do. Quantum destroys relativity. Yeah, the mainstream also just ignores that and claims relativity is still true. So yeah,
The
yeah,
way I think of the way
it's a basic phenomena that's known to exist now. Mind you, that wasn't always the case, and this was basically brushed under the rug. And at first, it was only very short distances, and it was barely over C. And then what they accomplished was a much longer distance with up to 3 to 3.5 C. So it's not like super basic. It's been known about for a really long time. The way Jace was trying to praise it. No, no, no. This is a relatively recent discovery, right? And yeah, they've obviously had no choice but to acknowledge it now. This is an easily replicated test, and it was done many times even within this test. And there were subsequent replications of this test. I looked at all the supposed rebuttals of it. There's only a few that even touched it. This basically got swept under the rug. The author himself comes out 2 years later explaining how much it messed with him and how he tried to make sense of it within relativity. So all that's cool, whatever. The mainstream wants to have their cake and eat it too, and say that quantum, that very clearly demonstrates phenomena that violates relativity, somehow can coexist with relativity while it refutes it. I don't care. I don't care if that's what the mainstream says, and I don't care if people are, naive enough to believe that or just force themselves into this existence of paradoxical nonsense or whatever, right? Like, in terms of reality, this claim that there's an absolute finite speed limit to matter, energy, and information in the universe is not correct. And
the way I was
we
picturing
can
it,
very
the way,
easily prove that with a test like, what's up,
the
man?
way I was picturing it a while ago when he was explaining interference and the way that I picture it working between two different frequencies. It's sort of like a pair of scissors that's cutting a piece of paper. Even though both sides of the scissors move at a certain speed as they close together, the point where the paper's being cut is moving a lot faster. And even though both sides of the scissors could never exceed the speed of light themselves, that point that's getting cut as the scissors are closing across down the paper can move faster than the speed of light.
Exactly,
Even though
Cole.
it's
That's exactly what it is.
so
It's exact analogy.
so when you got an interference, when you got two interfering frequencies, as they interfere across each other, that crossing of each other is moving faster than the speed of light, even though the frequencies aren't.
Exactly what it is.
So
It's exact analogy.
So when you got an interference, when you got two interfering frequencies, as they interfere across each other, that crossing of each other is moving faster than the speed of light, even though the frequencies aren't. But at the same time, if you start with no frequency at all and you flip the machine on, the frequencies have to travel down the thing at the speed of light. So how could the interference travel faster than
The
speed
interference
of
the interference can't travel past the first photon. So that's why the first photon has to have a sufficient head start before you start this group velocity thing. And like,
sounds.
So
where is any of that in the paper?
Frequencies together, then you could achieve information moving faster than the speed of light. If you just brought two frequencies that are already running together somehow, that interference would whip down through there.
yeah,
as
I
they
mean,
cross
like,
each other.
that's why they have to specifically define information, right?
Yeah. Well,
Because by like a colloquial sense, in a general colloquial sense of the word, yes, information would be traveling faster than light. That's why in physics they have a different meaning for the word information, and that's like normal and standard particle theory.
It's just causality. That's what information is. It's just a cause and effect. That's information being transferred.
Yeah, it sounds like we don't.
Okay,
really
but how is this
understand the
not
cause and
debunking?
effect
Are you
relationship.
trying to like save GR or something? Like, I feel like Witsit's point still stands and GR is debunked.
Yeah, it's just basically saying like, yeah, it does what we say it can't, but we're just going to say it can anyway. That's literally what's happening. It's the same thing they do with almost all of quantum mechanics, right? Quantum mechanics fundamentally is incompatible with both Newtonian and Einsteinian mechanics, but they just act like they can isolate that world from the rest of the world. They do the same thing with this phenomenon by saying things like, oh, well, the leading edge of the wave is all that matters, and that's the only thing that can be considered information. And when I started pressing them and saying, okay, wait, is a photon information? According to the mainstream, a photon is information. Okay, does the group velocity have photons? Is that pulse made of photons? I obviously don't believe in photons, but the phenomenon is real. It's the intersection point of the oscillating electric and magnetic field.
I'm fighting with you, Witsit, because I feel like that that information is traveling faster than the speed of light, so that would violate what Einstein said. And that's why I keep saying I'm not against you. I'm on your side on this. It just seems in my mind like that's information moving faster than the speed of light.
Well, it is objective.
And I would agree too, but they have their own way of defining information now to where that's not the case.
But the thing is,
so like when you say it is in the general colloquial sense of the word, the information is moving faster.
Real quick, Noah. Cole, you're on Witsit's side. This has successfully debunked GR.
Seems to me like it.
And that's
just
SR.
Completely misunderstanding something.
It does. And this is the thing that's weird anyway. Like, there's no reason in the mainstream globe heliocentric paradigm to defend GR anymore anyway. It's already been debunked. It doesn't work, right? If the Earth is a spinning ball flying through space, it is not because of general relativity. Now, this is well known. But, like, all that aside, it's not even like the phrase useful information is this ad hoc get out of jail card. That's all it is. And to be fair to the authors, they're pretty like upfront about that. They literally just say it's about how you choose to define the terms, right? And specifically what it says, just to read it again, right? Like, it's so goofy to me that they say this, but I understand why they say it, right? So I'm just gonna read it again. As in the case of analogous optical experiments, this highly superluminal group velocity can be understood as an interference effect between spectral components of the pulse. In the highly dispersive band gap region, frequency components tend to interfere destructively in the tail of the pulse and be reflected backward. Here's the important part. This effectively shifts the peak of the transmitted pulse forward in space. Although superluminal pulse propagation appears to violate the principle of causality, the issue is mostly a matter of definition. Group velocity, defined as the traveling speed of the peak or center of gravity of the pulse, which is basically just the center of mass average of the group, right? Although superluminal pulse propagation appears to violate the principle of causality, the issue is mostly a matter of definition. Group velocity, defined as the traveling speed of the peak or center of gravity of the pulse, can indeed exceed c or become negative. However, since the transmitted energy is at all times smaller than that of an equivalent pulse traveling through free space, no useful information can be sent at superluminal speed. That doesn't matter, right? In terms of physics, it doesn't matter if you can achieve superluminal communication using this phenomena, exactly how it's been observed. That doesn't matter. I'm not proposing it to say, yo, we could actually be talking on Discord faster than the speed of light. I don't care about that's irrelevant. Okay. The point is that this shows energy exceeding c. Now, to still man their side, they obviously are going to move everything around and claim, well, relativity doesn't say that nothing can go faster than the speed of light and blah, blah, blah. This isn't useful information and whatever. And I even got out ahead of this and said, W.G. Rossier, who is a world-renowned expert in relativity, he explained this decades ago, where he explained, contrary to the popular belief that's a misnomer that nothing can exceed c, even according to relativity's own principles in mathematics, if you're in the presence of a strong enough gravitational field, both matter and energy can far exceed c. So this is the stronger position if you want to try to hang on to the already falsified relativity paradigm, is to just claim that the way that everyone is told how it works, the way that everyone in this room as a glober was claiming it worked and misunderstands it and claims that nothing can go faster than speed is actually a misnomer that's not actually accurate, right? And in the presence of strong enough gravitational fields or big enough masses, it actually could exceed c. And, I mean, there you have a major problem. Now you've opened up the door for the dynamic equivalence of geocentrism with the Machian principle, which was previously dismissed because certain distances away would have to go faster than the speed of light. That no longer is a viable refutation of the Machian principle in relativity. The implications of this are massive, right? But it isn't my problem. I guess to just like land the plane here, right? Like, there is indeed a pulse. It gets propelled forward, and the propagation rate of the pulse that triggers this receiver, it's a physical interaction. It's not an illusion. It's nothing like that. It's a physical interaction with the receiver. The rate at which that pulse is propagated, triggering the receiver, is 3 to 3.5 times faster than the speed of light in a vacuum. And that has to be energy, or how could it trigger the receiver? Right? Like, obviously, for it to flip it on and receive and register the pulse, it is energy, right? And of course, it fundamentally is. We could go all the way down into it. If you believe it's photons, or how are photons not information? How are photons not energy? How is the constituent parts of light not energy? I don't care which part of light it is. It's an oscillating electric and an oscillating magnetic field. That is energy. This energy is propagating faster than the speed of light, which means we cannot claim that energy can't go faster than the speed of light. It absolutely can, right? So, I mean, I'm sorry about it. It just is what it is. Like, obviously, you can do mental gymnastics and revise the definitions and applications of relativity as needed to, keep your belief system alive or whatever. You can go that route if you want. But, like, true investigation clearly renders relativity false. And that's my point. That's why I brought it up. It was actually a comment in passing, and of course, they jumped on. All right, so rant over.
It's just amplitude.
Where in the paper can you show that they received the pulse faster, or they received the pulse at 3C?
That's the entire point of the paper. So I just read it, right? They say that, okay, I'll read it again. I'll read this part right here. So this effectively shifts the peak of the transmitted pulse forward in space. Although superluminal
Right there, right
pulse
there. Hang on, sorry. What, right there. It transports the peak of the wave forward faster than the speed of light. That's not the pulse itself. That's the peak. Like if you look at the GIF that I posted in live stream 1, you can see how the peaks where they peak is moving faster than the signal. The signal never moves faster than the speed of light. It's the peaks as they peak out
that I
that moves
you know,
faster
how does that rebut what I just said?
because the signal never gets to the receiver faster than the speed of light. It's just as it's moving at the speed of light,
That's
the
not true.
peaks
The
propagate
No,
forward.
signal's
That's
everywhere
exactly what it is.
simultaneously. The
That's
signal can
exactly what
never
it
be
is.
localized.
He's addressing Witsit.
the
Either way,
traveling speed of the peak
Of the peaks,
goes
yeah,
faster. The traveling speed of the
of
peak
the peak.
goes
Yeah, that's
faster
not
than
that's
the
not the
speed of
signal
light.
though.
Okay,
That's
let's
not the
think very
signal.
simple. Okay, let's think very. Oh, it's just a constituent part of it. So let's
Yes,
think very
if you
simple
look
here.
if you look at the GIF,
He said
if,
yes.
if you look at if you look at the GIF that I posted, you can see the peaks are moving faster than the signal speed. The peaks are moving
Th-
faster, not the
That
signal itself.
that doesn't help you.
Why? Because
Doesn't help
it's not going
you.
to it's not going to be received at the end any faster than the speed of light
It
because the
literally
signal's not going
is.
fast. No, show me the paper where it says that. It's
That's
telling you that that's a
okay.
signal
Here,
peak.
let's think about this really simple. How did they measure it? How do they know that something went fast? How do they know that the peak went faster than speed of light? How do they measure it?
It's the interference pattern between the two different wavelengths.
How they measure it?
I'm not entirely sure of how they measured it, but I'm just explaining the principle of it. It's
I
not that
am.
the signal it's
I
not that
am.
the signal gets it's not that the signal gets there faster than the speed of light because it can't get there faster than the speed of light. But the wave peaks,
Oh,
the peak, like if you look at the GIF that I posted, you can see the wave peaks, the way where they peak up. That moves faster along in the animation than the actual signal does, and it's that propagation of the peaks of the wave peaks, like you just read it at the beginning of that statement you're about to read. The wave peaks are moving faster than the speed of light, not the signal itself.
oh. So where are they moving to?
Along the signal, the length as the signal's
Oh,
moving, the peaks are moving faster than the signal, and they stop where the
oh,
signal where the front the wave front of the signal is.
oh. Okay. So if there's a wave front and then the middle of the signal is moving 3C, which one would get there first?
Only the think of it
what is he calling the signal? What are you even
think of it
calling the
like
signal?
think of it like you're pulling out a length of an electrically live line, and as you can pull that as fast as you can, but the electricity is not going past the beginning of that line. That's like the signal. As the signal propagates, the waves are moving faster along the signal, but they can't go ahead of the signal because there's no waves there for the wave peaks to move past.
Where does the signal go to? Where does the peak go?
The peak goes from the end of the signal to the front of the signal, but doesn't go past the front of the signal.
Okay, so the peak moves forward in space, quote unquote, to where?
It's not just the peak. It's that if you look at my GIF, the wave the wave goes up and down, right? And you can see where it goes up and down, and where it goes up, that part moves along the signal, and it's where they peak out. The wave peaks, like you read off. You started to read that thing. It said the wave peaks propagate faster than the speed of light. That's what it's talking about. It's talking about the movement of those wave peaks.
Notice how you're not answering my question?
He made a
I did.
point.
No, he ignored my question 3 times.
Oh,
So,
no, I didn't ignore it 3 times. Say the question again.
okay, where does it go?
The signal goes from where they transmit it to where it's received.
Okay, so it goes to the receiver.
Yeah, the signal does. Yes.
Wait. Does the pulse go? The pulse that's measured at 3C, does it go to the receiver?
Dude, the signal goes everywhere, Echoplex. I don't know why you're not addressing that, dude.
The
It can
signal
never be
goes.
localized. He's just gonna ignore me.
The signal goes, and then the wave front or the wave peaks move faster than like they propagate faster, but they don't go past the front of the signal. Like as the signal's moving, it's like if you look at the GIF, like I said, it makes it so much simpler if you look at the visual for it. The peaks of that wave are moving across faster than the signal is.
You still just can't answer. So it goes to the receiver.
Yeah, well, the wave peaks are a part of the signal. So if the signal gets there, the wave peaks get there as well. But the wave peaks move independent, like they don't move independently. They move along the signal, but they move faster than the speed of light. But the signal only moves at the speed of light.
And so the peak moves forward. It gets propelled forward in space to the receiver faster than the speed of light.
No, it doesn't. It doesn't get to the receiver faster than the speed of light. It moves along the signal faster than the speed of light. The signal only goes the speed of light, and the wave peaks.
Dude, you're talking out of your ass, bro.
How do
No,
you
if
think
you
they're
if you
measuring?
look
How do you think they're measuring 3C? I think they measure it.
with an oscilloscope, they got the wave showing up on the oscilloscope, and the peaks are moving across like they're moving faster than the speed of light.
You're just looking at it.
Like I'm not sure what the exact
Oh,
equipment
I
is.
am. I got you.
But if you
I got you.
what I'm saying is, if you look at the GIF, like I said, the peaks are moving faster than the wave is, the wave front. I don't understand why
Okay.
this is hard to understand.
Oh, I'm not the one that's confused. So, how are they measuring the rate of propagation?
I'm not
They're
sure
using the
of
receiver.
that. I'm not sure. No, it's not. How can they use the receive like with
What?
the
What?
movement of the waves? The movement of the waves are moving across the coaxial cable. So how can they use where it ends up the receiver to measure the signal of the wave peaks?
What? They're using a receiver that's going to register the pulse once it gets
Yes.
there, and that's how they're going to get the propagation rate.
Yeah,
You
but
just
that's
now
not.
said they're just
But that.
looking at it.
But they're not getting that signal faster than the speed of light. Is the point?
Is the pulse going to the receiver and being measured using the receiver at faster than the speed of light?
No, it's not being measured at faster than the speed of light.
Oh, how do they know what the speed is then?
The speed is the speed of light, but it's the wave peak propagation that's going faster than the speed of light. It's not the
How are they
signal.
measuring that?
With an oscilloscope, you get a readout of the wave pattern, waveform or whatever.
Wait, you're saying that they looked at a graph and then they measured how fast the signal was going?
Well, if you look at the GIF that I have on there, you can see that the wave peaks are moving faster than the signal is. That's
Okay.
what they're measuring. They're measuring how fast the peaks are moving across, not the
Across.
signal. Yeah,
Okay. Does it randomly stop moving forward?
just randomly stop moving forward.
Does the pulse that's moving forward faster than the speed of light, does it just stop moving?
No, the pulse goes, and they're
Oh,
measuring the wave peaks. If you read that thing again, it says it right, that first sentence. It says it right at the beginning. The wave peaks propagate faster than the speed of light. That's not the signal propagating faster than the speed of light.
dude, you just keep saying that same sentence as though it's a rebuttal.
Because I'm explaining what the experiment is. They're not reading the
Dude,
signal moving faster than the speed of light.
dude, you
They
just
move,
keep saying it over and over, bro. Like we've already
Yeah,
discussed
I'm not addressing
multiple
anything that's
times.
being said
Yeah.
to him either.
Like, and like, let's think about this really simply, right?
using
Like,
everything. What are you talking
let's
about?
see if you can answer this.
I've said several things to you.
What is moving faster than the speed of light in this test?
The wave peak propagation.
Okay,
Propagation
what is
of the wave peaks. Yeah.
okay? So what is that? What is it?
That is it. If you look at the GIF that I posted, it's the part of that signal, like it's making like a wave going up and down. It's how fast the peaks of those waves It's how fast that's moving along the signal. That's what's
What is it
being
that's
measured.
moving?
What do you mean?
What's moving?
What do you mean? I pointed out that the wave peaks are moving.
Okay, but
That's
what wave peaks of what?
of the signal.
What kind of signal?
I don't know what the kind of signal is. The signal that they're using to do the experiment.
You don't even know what it is?
What kind of different what different signals can there be? Like, I don't understand what your point is.
Well, there are different signals. It could be light. It could be an electrical signal. It could be.
Okay, yeah, it's electrical signal for the coaxial cable experiment. It's electrical signal.
Okay, so it's an electrical signal.
Yeah.
Okay, is electrical signal energy?
Yes.
Okay, so a constituent part of the electrical signal that is energy is moving faster than the speed of light.
Yeah, the wave peak is
It
propagating
doesn't
faster
matter
than the
if you
speed of
just say
light.
the phrase over and over as if somehow it stops being what it is. It's energy, right?
No. It's the wave peak that's moving faster. It's
Oh, so
not.
that's not energy.
That's not. No, it's not. It's not. It's not the signal. Is what it
Well,
is.
hold
It's
on. Let me
not.
ask him.
Not the signal. It's a
A
part of the
wave of
signal.
what? A wave of what? A wave of what, Echoplex? I know you want to ignore me, but waves aren't things of themselves. So what are you referring to when you say a
Okay,
wave?
you
A
need to
wave of
slow this
what?
bullshit. No, I'm not answering this because this is just stupid.
What do you
You're
mean it's
completely
stupid?
distracted.
How is
You're
that
completely
stupid?
because this is just retarded. This is your
Don't
way of
spiral
throwing a
this fast,
spanner.
man.
This is a way of throwing a spanner into the conversation to completely derail it onto something that's absolutely has nothing to do with what we're talking about.
Really?
So that's why I'm not answering it. Yes.
Witsit, am I out of pocket here?
No,
Why
no,
can't
because specifically what he's avoiding is what
Okay,
it is
this is
that's
just
moving.
this is dishonest. So I'm done. I'm not engaging.
excellent.
Gabriel, you
Okay.
got
Okay.
nothing. I don't even know why you're
Okay.
talking.
I can.
Do you not get why the reason that Daislow's question actually is relevant? I know that you're triggered because you know he's gonna make the point he normally makes, which after 5 years I've heard none of you guys actually rebut. But
It's
like
retarded. It's
it
retarded.
it actually it's not retarded, or you'd be able to rebut it. But the actual point is very relevant right now because you're avoiding what it is that's moving. You just keep on saying like the wave peak as though it's strictly some abstract mathematical entity that creates the illusion on our
Read
graph
the first.
that something
Read the first
is
sentence.
something
Read the
in
first sentence.
physical reality that is
Read the first
energy
sentence.
moving faster
Read
than
the
the
first
speed.
sentence.
Dude, there's
Read
a
the
zero
first.
percent
Read the first
chance that
sentence.
you're listening to me because you're talking at
Read
the same time.
read the first sentence again, and that tells you what is moving faster than the speed of light, and it's not the signal.
Okay, so let's see if you can listen. Is something in physical reality moving faster than the speed of light?
Just give us the whole spiel.
Yes.
We've been at this for 2 hours.
Yes.
Just give it to us
Yes, it is.
straight.
Give
Yes,
it
it
to
is,
you
dude. I
straight.
mean,
How much more simple could I make it than that question, bro?
it is moving faster than light. Yes.
Okay, do you agree,
A
guy that's jumping in?
constituent part of the photon is moving faster than light. Sorry.
Or well, yeah. I mean, you're into there will be photons all along that arc, right? According to them, but yeah. So something in physical reality that is part of an electrical signal, and really it is the electrical signal, right? The electrical signal is just moving in a certain way that you really can't even break it up into like separate entities. To act like the peak of the wave function is something separate than the signal makes no sense at all. It
Right.
is just
Yeah.
the electrical signal, right? And it's moving a certain way, and based on its movement within a certain detectable type of movement of that electrical signal, it propagates forward faster than the speed of light. So it doesn't
Okay.
matter if
So
you just try to like pretend it's something separate, right? It still is the effects is the same, right? Like the physical reality is that electrical signal is moving forward, propelled through space faster than c.
no, not really. The signal can exceed the speed of light, but once the signal arrives, like the interference in the signal can move faster than the speed of light. You
Exactly.
can't
That's what I'm talking
have
about.
you can't have the
Right,
three
that's
C. you can't have the 3C. You can't have the 3C pulse, like the pulse faster than the speed of light, 3 times faster than the speed of light, without having the signal arrive beforehand, essentially.
Yeah, but there's still
The
an
interference is the signal.
It's not. It's not though. The interference is what
No, yeah,
literally
no. The
is.
interference is like the interference is is like a constituent of the signal.
Well, it's actually just the signal. It's just it's just how the signal's moving. So, like, if I use interferometry and I have light that intersects, right? Like that place that it intersects is light intersecting, right? So intersecting, waving, these are descriptions of movement of something. That something is an electrical signal in this case. So the fact that there is interference isn't a separate corporeal entity or something. It's a description of what the signal's doing. That's all it is. So like to
It's a
separate
constituent of
that,
the signal. It's a
well,
constituent of the signal. It cannot exceed the signal. The signal arrives, and then now that the signal has arrived, you can now change like the phase of that signal, and that change in phase can move faster than the actual like signal does, except it won't ever it when it catches up to the front of like the group velocity, that phase will actually slow down to the speed of light, and it won't exceed the front of the signal.
yeah, but
Essentially,
I think everyone acknowledged that. I think it's like the point here is that there's an event, a physical event that's happening faster than the speed of light, according to this. A physical
specifically it's the electrical signal, right? Like constituent part is actually, I mean, I'm being super charitable in this discussion for intents and purposes, kind of to avoid the road that I know Dyslow is chomping at the bit to go down, which I think is more accurate. I'm being super charitable, right, with the terms being thrown around. But where I can no longer do that is where we invoke a mathematical description of motion and then claim it's a separate constituent part of the signal. It is actually just the way the signal's moving. It's what the signal's doing, right? That's all
It's
that
not.
it is.
It's not the signal though.
no. Okay,
It's
wait.
not the
I'll say it
signal.
like this. I'll say it like this, dude. So there's Witsit, and you're the metaphor for the photon is your body. Okay, it does not even just body. Okay, so your body is, I don't know, you're running, right? Then there's your 2 fists, Witsit. Right? Those you can consider those like a phase velocity or a peak of the like one of those peaks that this guy's talking about. You have your maximum speed of running. Let's say you're, I don't know, let's say you're tall and skinny. Let's say you're running 20 miles an hour and that's your maximum speed. Okay. Your fists being these interference patterns, as you're running 20 miles an hour, you can throw a punch. And because you're running and that punch is say 5 miles an hour, that punch is going at 25 miles an hour. So it's exceeding your maximum velocity of 20 miles per hour. But that punch can't go past the end of your arm. So like it can only go faster than your maximum speed if your body has already kind of run that far, essentially. I don't know. It's not the best
That's exactly.
analogy, but there you go.
No, that's exactly it. That's exactly it.
That doesn't change what I'm saying at all. Like we have the electrical signal. What we do is when you say wave function, waves actually aren't a thing, just like Dyslow said, right? It's a description of a type of motion. Okay. We can isolate different parts of that motion and we describe them mathematically with wave functions. That's cool and all. But the wave function is describing the motion of the signal. That's all that it is. What we're seeing here is that a certain portion of the signal, right, is propagating forward faster than C. So to say like, oh, well, it's just a part of this other thing and you can't have the part of the thing without the whole thing doesn't matter. The fact of the matter is that an electrical signal, right, like it is moving forward in quote unquote space faster than the speed of light. That's what it's doing. It doesn't matter if it's within like a previous like leading wave front or anything. Like the fact of the matter is the electrical signal, right? And it's a specific frequency and they're using a specific type of impedance. right? And they're using that frequency, basically overlapping and intersecting based on different cables using a photonic crystal. And when that basically scatters and interacts within that medium, it then it propels it forward faster than the speed of light. So much so that it's as though it was like there before it was sent almost. Okay, so like you know, whatever, bro. Like of course what they're discovering is that when you do certain things with electrical signals, right, you put it in certain scenarios and then cause it to take a certain modality or form, that's when it then propagates faster. So like to say like, well, it only happens this way, or it only happens within it once the phenomena starts, or anything like that, is all non sequitur to the point that the electrical signal, right, is propagating forward faster than the speed of light. And mind you, I don't even believe that. I
No,
don't
that's
believe it's
incorrect.
going
Yeah.
forward at all. Well, okay.
So it's not
Noah,
you're misunderstood. You're not using the word signal correctly. It's not the signal. It's the interference. The interference is not. It's not coming before the signal. The signal has to be established, and then the interference pattern, yes, is moving faster than the speed of light, but it is not moving ahead of the signal, and the signal is
Right.
not
So
moving
you keep
faster
on
than the
adding
speed.
that last part there, right? Like moving ahead of the signal. Like the interference is an event. It's not something in and of itself. It isn't a corporeal entity.
That's I agree. Yeah.
So it's an event, and that event
Yes, and
is
that
the
event is moving faster than the
intersection.
speed of light.
Well, not the event is not moving, right? So it's
Yeah, it
like
is, dude.
no, it's just that once the event happens, then the signal moves faster because the
No, you're
event isn't
misunderstanding
something.
what signal means, bro.
No, I'm not. What the whole thing beginning to
You're
end called
conflating
an
the
electrical
interference
signal?
with the signal.
No, you're saying that the interference is something separate than the signal, even though the truth is that the interference is just an event
They
describing
are they
something
are
at the
two
speed of
different
light.
things.
No,
One
they're not.
one is like the signal or the photon is the cause of the interference pattern. The interference pattern is like a constituent part of the photon. So they are like, it's like saying your fist versus you Witsit. Your fist is like different from you as a whole, yes, but it is like a part of you. Just like the interference pattern is different from the photon as a whole because it is part of the photon. Your fist is different from you because it's a part of you.
Yeah, that's why I said that analogy is no good. It's like this analogy isn't perfect either, but the more applicable analogy would be like me, Witsit, I'm going to do the worm on the ground. And you're saying that the worm, the dance move, is a separate corporeal entity from Witsit, but it's not. It's how Witsit is moving. I don't matter if you point to the center of my body and show it moving.
Okay. In the case of you doing the worm, let's say you can do the worm and your body can travel across the floor at 1 mile per hour doing the worm. All right. In this metaphor, your maximum body's velocity is 1 mile per hour. The wave of the worm in your body going at 2 miles per hour would be directly analogous to the phase velocity. And that phase velocity, let's say it's going 3 miles per hour, 3c, 3 times the maximum speed of your body moving. That wave through your body can exceed the speed of your body, but it can't travel past the end of your body. So that's why, like,
Of course.
your body would be the signal. So your body being the signal can't possibly, like, the wave going through your body can't exceed or go before the signal, which is your body in this analogy.
But bro, that isn't the point, right? It's like my body moving is the worm. If I look at my waist to my nipple, right, and I'm like, yo, this part of it's moving faster, right? It's like, okay, what is moving? My body still moving in a motion that we call the worm. An intersection is an event. It is a characteristic of the motion of the signal. That's all that it is, right? It is not something in and of itself. It's also in this paradigm photons. Photons are overlapping and intersecting. The light or the electrical signal, right? It is its own thing, beginning to end. and we're looking and seeing that it has a characteristic within it, intersection. That's just a type of motion. It's like if all of a sudden we could freeze time, if Frieza could come in and shoot something and bam, it all just stops for a second. If I look beginning to end from that signal, the whole thing's a signal. Even if it stops, even if it starts moving again, right? It's all a signal. Intersection is just a description of the motion of the signal. That's all that it is. What's being done here is to say that the peak of the wave function, so which is just the top portion of the type of motion of the signal, is somehow something separate than the signal. It literally isn't. It's
So
just
the peak in the
So
signal, the peak in
what
the
you guys are
signal would be
missing
like
is
the peak in your
modulation.
back
That's the
while you're
word that
doing a
you guys are
wave.
looking for that you're missing.
So
So the
clearly,
signal's everywhere, can never be localized. You can never localize the signal in one specific Cartesian area, right? So what you're talking about is modulation. You're welcome.
like the peak in my back is still my back. It's still my body, bro. Like that's
yeah, but I'm saying the peak in your back. So the peak that starts at your heel moves up to the back of your knees, to your butt, down to your back, all the way up to your back of your shoulders, up to your head. That wave, as you're doing the worm on the ground, if that wave is going at 3C and C is the fastest your body
Bro, isn't everyone just
you see
acknowledging
the
that?
wave, that constituent in your back that's moving, it's moving at 3C, but your body's moving at 1C. When that wave gets to the end of your body being analogous to the signal, it doesn't move past your body, it just ends.
Dude, why is everyone repeating that point? That's not the point. Everyone
I
agrees
know,
with
it's just weird. It's weird.
Did
It's
you
like
think
literally non sequitur.
do you think there's I use the word physical event before, and I think Witsit adopted too. It's good. I think how about this? There's a physical change that's occurring faster than the speed of light. There's a change in physical reality that's occurring faster than the speed of light. Doesn't matter which thing reaches first, what reaches first, it doesn't matter. Some
That's
physical
not a
change.
problem, though.
A
A
problem for who?
portion, and it's not a problem for who? Just because they say it's not a problem? Like a portion of the signal, if you want to say it that way, right? Because imagine if I just shorten it. Imagine if I put the receiver up 10 yards, so now the signal can only go so far. Well, we would call that a signal. Now we're going to double the length. Okay, now that's the signal. Once we double the length, what was previously the end of it is now in the middle, and that's where this is occurring. It's still the signal. Okay, the signal just is there. There are certain portions of the signal. It's moving. We're describing the motion, right? We do this with mathematical wave functions. They have a peak. There's intersections within the motion of this wave function, right? Okay, cool. Those are all descriptions of the signal and how it's moving, how it's behaving. That means that the signal, if you would rather say a portion of the signal is moving faster than the speed of light. It is not something separate than the electrical signal. It is nothing like wave function is just a mathematical description. That's all that it is. The math is not moving faster than the speed of light. It's the signal. It's that portion of the signal that's moving faster than the speed of light, not the math. The math isn't moving faster than the speed of light. Interference patterns are our descriptions of the signal and how it's moving, right? So the interference, the wave function, the math isn't what's moving faster than the speed of light. It's the actual electrical signal, which is energy and information by definition. Although both of those things are not always define the best in physics, but that's what's moving, right? And this is a problem for relativity because it fundamentally claims that there's a universal speed limit to energy. And there's no way to take a portion of the electrical signal and say that it isn't energy, right? Like, how would that make any sense? And that's kind of the question I've asked for a while. No one has directly answered. How can the signal be energy, but if I take a portion of the signal, it's not energy?
I mean, I have yet to hear anyone define what the signal is when pressed on it.
It's
I know. I was just
stream of electrons or whatever.
I was just super charitable in this discussion. At this point, it's getting
No, I
redundant.
know.
I think you can. I'd actually rather you make your point about it.
Well, no, I'm just saying. You're kind of giving them enough rope to hang themselves, right? But they're refusing to do it, and they just want to keep regurgitating the same points. Ecoplex already left, so I don't know. I'm not gonna beat Noah over the head with either. He's already heard my spiel. Go ahead,
So I just for me, it's just perplexing. Like literally, I heard 20 times someone say, "But it'll never go beyond the leading edge." Who cares? Like it's just 20 fucking times the same thing, as if people don't understand.
Because the leading edge is capped at the speed of light.
Yeah, but everyone acknowledges that. That's not the point.
Yeah, like really all that point demonstrates is that to achieve the phenomena of superluminal propagation or for energy to go faster than the speed of light, that the initial propagation must take place first. Okay. Can someone cite in relativity where it says that's the there's a disclaimer in relativity where it says unless propagation occurs first. Like no, it says energy can't move faster than the speed of light. We're talking 3 to 3.5 C, bro. It's like not even close to the alleged universal speed limit.